It's exercise A. Let's do it. So the first question is f of x is x when x is bigger than 1 and x squared when x is less than 1. Then the limit as x approaches 1 of f of x is. So if x approaches 1 minus, which is the left hand limit, we have to use x squared. So that will be 1, right? So 1 minus squared, that thing is 1 plus. No, wait, that's not 1 plus. That's also 1 minus, in fact. Yeah, but in the end it's just 1. Okay, so yeah, that's nice. And when x is bigger than 1, that is when x approaches 1 plus, we have to use f of x equal to x. So f of 1 plus is 1 plus, which is tending to 1. So both LHL and RHL are tending to 1, so that will be the limit. Next question. Okay, so this is basically a signum function. So the LHL is -1, RHL is 1, so this does not exist. Cool. Okay, so f of x is 2 upon 5 minus x. Fine. So first of all, the first thing they want to find is limit as x approaches 3 plus. Okay, so 3 plus means it's bigger than 3. So f of x equal to 5 minus x. So f of 3 plus will be 5 minus 3 plus, which is 2 minus, right? That should make sense. So it should be 2. Okay, fine. So this is going to be 2. And what else do we have? And okay, 3 minus stuff. So f of 3 minus. Yeah, so that should be 1, right? So this is obviously correct. And this thing, as x approaches 3 plus, you get of x equal to 0. Wait, no, that's not correct. X approaches 3 plus, x is bigger than 3, 5 minus 3 is 2. So, well, A and B are not correct, so C is correct. Well, okay, fine. Let's go to the next question. Okay, so first we need to find LHL. Alright, so f of 1 minus, right? So for that case we have to use this thing, right? The first one, which is 0 less than or equal to x less than or equal to 1. Yeah, that's going to be like 3 times 1, which is 3. Cool. And if it is bigger than 1, which is 1 plus, basically we will be using 5 minus 3, which is equal to 2. So no, this thing is RHL, this thing is LHL. This is pretty clear that the limit does not exist. Next question. Right, this should be like that. Okay, so the next question is limit x tends to 0 of mod x upon x is. Right, so it tends to 0. So basically this is just the signum function. So this does not exist because the graph is something like this. The graph of mod x upon x is something like this, right? And this point is 0. Fine. Next question. Oh, this is a polynomial function. Fine. So the good thing about polynomial functions is that they are continuous. So we can just put 1 into that thing and we will get the answer. So this is going to be 3 plus 4 plus 5, which is 12. Nice. Next question. Okay, the value of limit x approaches 2 of 3 to the power of x upon 2 minus 3 upon 3 to the power of x minus 9 is. Right, so this thing is just 3 to the power of x upon 2 minus 3. Okay, wait a second. Okay, fine. Minus 3 upon 3 to the power of x upon 2 minus 3 into 3 to the power of x upon 2 plus 3, right? And we have the limit as x approaches 2 of this thing, right? So this thing is just gonna get cancelled. So this is equal to the limit as x approaches 2 of 1 upon 3 to the power of x upon 2 plus 3. Just put 2 into that, you should get 6, right? So this is 1 upon 6. Nice. So cool, let's go to the next question. The value of limit as x approaches a of x to the 5 minus a to the 5 upon, yeah, this is also doable. So this is just like limit x approaches a of x to the oh yeah, what is this, x to the 4 times a. Is that like, no, not like that. This is x minus a into the x into x power 4 plus ax cubed plus a squared x plus a cubed. Yeah, that's more like it. Into x minus a upon x minus a, so that gets cancelled, right? So this is just going to be a power 4 plus a power 4 plus a power 4 plus a power 4, right? Yeah, it should be square over there. Just a cube x plus a power 4, sorry. So 5 times of this a power 4 stuff, so that's going to be 5 a power 4. Nice. So that's also very doable. H approaches 0 of this thing, right? So let's just do this. So 1 upon h into x minus h upon x into x plus h, right? Which is 1 upon h into minus h upon x into x plus h, which is negative 1 upon x into x plus h. Now this limit, say this is L, then L is limit as h approaches 0 of negative 1 upon x into x plus h, which is obviously negative 1 upon x squared. Cool. So this is just negative 1 upon x squared. Next question. Limit x tends to 0 of square root of 1 minus x squared minus square root of 1 plus x squared upon x squared. No big deal. Let's just do this. Yeah. Rationalize this thing maybe. Yeah. So that's going to be 1 minus x squared minus of 1 plus x squared upon x squared, and then square root of 1 minus x squared plus square root of 1 plus x, yeah, 1 plus x squared. This is just going to be, what's this thing? This is just minus 2 x squared upon x squared gets cancelled. And square root of 1 minus x squared plus square root of 1 plus x squared. Then just put x equal to 0 into this thing, so this should be negative 1. Right. Next question. So the limit as x tends to 3 of x minus 3 upon square root of x minus 2 into minus square root of 4 minus x, okay, equals, right? It's just rationalization once again. So it says x minus 3 subtract, right? So that should be 2x minus 6, okay? And over here you should be having, when you put 3 into this, you just get square root of 1 and square root of 1. So this should be 2, right? And yeah, this should be 2x minus 6 upon 2x minus 6, which is 1. So that's the limit. Next question. Okay, limit x tends to infinity of, so was there a does not exist option anywhere in the previous question? No. So yeah, this is obviously correct. Next question is the limit x tends to infinity of ax squared plus bx plus c upon tx squared plus ax plus f. Right. So this is x tends to infinity. I think this is very doable, right? So it's just going to be limit x tends to infinity of a plus b upon x plus c upon x squared upon d plus e upon x plus f upon x squared, which is the limit as 1 upon x tends to, oops, this is infinity, right? 1 upon x tends to 0 of a plus b into 1 upon x plus c into 1 upon x squared upon d plus e into 1 upon x plus f into 1 upon x squared, which is just a upon d, sorry. Okay, that's doable. So the next question, this is very very obvious. Next question is limit as x tends to infinity of, oh, or this thing is equal to square root of x plus square root of x plus square root of x, okay, minus the square root of x. um yeah, so this is basically an infinity minus infinity situation. What should we do? I think we can do it like that. Okay, so this is going to be square root of x, square root of 1 plus upon the square root of x, right? Wait, is that correct? Yeah, so multiply by square root of x and divide by square root of x, so this should be correct. Minus the square root of x, which is square root of x into square root of 1 plus square root of 1 plus I don't know what I'm doing. Yeah, so it should be 1 plus square root of x. I think that's correct. Yes. Okay. Minus 1. Okay, now what? Yeah, so maybe we can use maybe we can use the general binomial. Wait, we don't need to do that. Yeah, we don't need to do that. Just put um just put infinity over there, so this should be like square root of 1 plus 1. No, that is not good. Oh, sorry, it should be 1 upon square root of x. Right, that makes sense. Oh, okay. So now what? Maybe we can kind of rationalize this thing. Okay, if we try to rationalize this, yeah, that's gonna be really bad. I don't think we will have any success doing that. I mean, we can try, but no, that's not a fruitful result that we are getting. So let's just try to do this using the general binomial theorem. So this is going to be square root of x, and then this thing is 1 plus 1 by 2 square root of 1 plus 1 upon square root of x. Wait a second. No, 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 no. That's not nice. Oh. Now what? Try rationalizing maybe. Yeah, we could. Okay, so this limit over there, this is just square root of 2 minus 1. This is so weird. Right. Oh shit. Oh, I got it. I got where we went wrong in this. So it should be an x over there, not square root of x. Man, this is not nice. Okay, so in that case, this thing is just square root of x plus, yeah, just the same thing, right? So square root of x upon x. Now that we have sorted that thing out, let's look at this thing. This thing does approach 0, right? So this is like infinity into 0 situation now, and the good thing is that now we can do this. Oops, what I'm talking about is, just erase all this stuff. So what we can do is that we can set u to be square root of x plus square root of x upon x. So this is tending to 0, isn't it? Because x tending to infinity. So this thing is just like square root of x into square root of 1 plus u minus 1. And we got an extremely helpful tool for this, which is called the general binomial theorem. So we can write this as 1 plus 1 by 2u plus u squared times some other stuff. So this is going to be, and this stuff, I don't think it's finite exactly. No, it's not finite. Wait, no, it is finite. Sorry, yes, it's finite. It's approaching some certain value. We don't care about what that value is. Okay, fine. So this is just going to be square root of x times so this is just 1 by 2u plus u square times other stuff, which is u square root x into 1 by 2 plus u times some other stuff, which is, now let's substitute u back into this thing, right? So u was this square root of okay, on x is square root of x. So this cancels, you get square root of x over there, you get half plus u into some other stuff. So this should be square root of 1 plus 1 upon square root of x. Yes, into half plus u times some other stuff. So look, this thing approaches 0, this thing approaches 0. So in effect, this complete thing approaches square root of 1 into half, which is 1 by 2. That was easy. Okay, next question. Limit x approaches 1 of x to the power of x. Oh, right. X to the power of x, that shouldn't be big deal. I mean, it is supposed to be 1, right? Or is it? Come on, who am I? What is this, man? It should be 1. What else can even be? I mean, 1 plus to the power of 1 plus. I mean, that's a finite quantity and it is very near to 1, right? X approaches, okay, x to the power of x, it does approach 1. Yes. Yeah, sure. There's no big deal in that. Okay. Yeah, I'm very sure that this is going to be like that. Okay, next question. The limit as x approaches 1 of 1 plus x to the power of 1 upon x. Oh, so this is going to be e. No, it approaches 1, it does not approach 0. If it were to approach 0, then this thing would be e. So as this thing is approaching 1, it should be 2, right? Because yes, it should be 2, because this 1 upon x is going to approach 1, and this is like 2 to the power of 1. Yes, it's obviously 2. Next question. X approaches pi by 6, 3 sine x minus. Alright. So how are we going to do this? Okay, this is x minus pi by 6, right? I think we can do this. I think we can. So this thing can be written as, let's take square root 3 common. So it will be square root 3 sine x minus cosine x. And let's do this thing. Oops, what did I do? Let's do this thing. Okay, and in the denominator you have 6 into x minus pi by 6, right? So this is going to be yeah, so this is just that thing times square root 3. So 1 upon square root 3 into sine of x minus pi by 6, right? So sine of x minus pi by 6 upon x minus pi by 6. Okay, so this is like limit as x minus pi by 6 approaches 0 of 1 by square root 3 sine of x minus pi by 6 upon x minus pi by 6. And we know this thing approaches 1. So this is just going to be 1 by square root of 3. That was easy. Next question. Okay. X cube minus x squared minus 18 upon x minus 3. Factorize real fast. X cube minus x minus. Okay. Any obvious solutions? Maybe. So 18 is like, maybe try 3. So 3 is going to be 27. 27 minus 9 minus 18. Yeah, that works. So x minus 3 is a factor of this thing. X minus 3 is a factor of x cubed minus x squared minus 18. So let's just do this x squared. So x cubed minus 3x squared. Subtract, you should get 2x squared minus 18. So this is just plus 2 into x plus 3, right? So this is just x squared plus 2x plus 3. Yeah, that's it. So x squared plus 2x plus 3 into x minus 3 upon x minus 3, right? And this cancels. So it's just x squared plus 2x plus 3. And it's at x tends to 3. So the limit as x tends to 3 of this thing, it just is 9 plus 6 plus 3. 12 plus 6 is 18. Next question. The next question is the value of the limit of x cube minus 8 upon x squared minus 4. Come on, this is boring. So yeah, it's just x minus 2 into x squared plus, ouch, it hurts, x squared plus 2x plus 2 squared, which is 4, upon x minus 2 into x plus 2, right? So limit as x approaches 2 of this thing, so this cancels, so you just get 4 plus 4 plus 4 upon 4. This was easy. So this should be 3. Next question is limit as x tends to 0 of this thing. Yeah, rationalize. Just rationalize this. So x, yeah, cool. This is going to be like x times square root of 1 plus x plus square root of 1 minus x upon, so this should be 2x. Yeah, it should be 2x. So this cancels. So this is just, when you put 0 into this, you just get 2 in the numerator, so this is just 1. Okay, x approaches a of this thing, right? Yeah, factorize, no, rationalize. Yeah, rationalize, correct. It's going to be subtract a minus x, subtract 3a minus 3x, right? So this thing can be written as square root of 4x, and then we are rationalizing, and then just put x equal to a into that. So this should be square root of 4a plus square root of 4a upon square root of 3a plus square root of 3a, right? So this is just 1 upon 3, and then this is 2a plus 2a, which, sorry, 2 square root a plus 2 square root a, which is 4 square root a, upon 2 square root 3 square root a. So it's a over there, cancels, so you just get 2 upon 3 square root 3, correct. So this should be the answer. Next question. As n approaches infinity of 1 to the power of 99 plus 2 to the power of 99 and so on. N approaches infinity, right? Okay, so how am I supposed to be doing this? Alright, so just think a little. This is definitely an infinity by infinity situation, right? Can I just take the, no, I cannot take the derivative. This is like n is an integer, so that's a real problem. And to the power of, how can I do this? Okay, maybe 1 power 100 upon 1. Think, we have not studied this series anyway, so I don't know how to be doing this. What kind of series is this anyway? Is raised to n power? I don't think that's going to be fine. So limit as n approaches infinity of this thing, The last one is obviously approaching 0. Yeah, but I'm not getting anything from this question. If we tried subtracting 1, okay, we could do that. So if I try subtracting, oh hey, I know how to do this, right? So we have to do this thing first. So the limit as n approaches infinity, okay, maybe not use n, let's use x approaches infinity. Wait, was that x approaches infinity, of what was it exactly? I don't know really. So 1 to the 99 minus 1 to the 99. Oh, but that's gonna be really bad. I don't want to do that at all. Okay. Still, let's try it out. So for example, 3 power 99 minus 1. I think it's going to be 3 minus 1, which is 2 into 3 power 99. This is not gonna work. This is not going to work. Maybe try a recursion. Yeah, we can try a recursion. Okay, so this is a quite complicated question, and I think I know how to do this. So let's define this thing to be like, okay, f of n, not n exactly, I want to use something else. So say f of m is 1 power m plus 2 power m all the way till n power m. Okay, so we know like 1 plus 2 plus so on till n. Yeah, okay, wait a second. What I'm doing, this thing, okay. What am I writing once again? I was supposed to write something else. Okay, I think I got it. F of m plus 1, or maybe m minus 1. M minus 1, that is going to be 1 power m minus 1 plus 2 power m minus 1, and so on, right? So it's going to be n power m minus 1, and then try subtracting that. Well, no, that's not nice. This is so frustrating. Upon 2 minus 1, it's going to be that. You can make a GP out of that. Yeah, sure, but no, that's not gonna work. Come on, that's not going to work. Obviously, we know that. Right, we cannot get that value in any ways. We have to think of something else. I don't know. I think I will do this the next time. Yeah. I really wish there was some kind of recursion that I could get. So if let's go for the smaller cases. If n is 1, then this thing is going to be just 1. Okay, if n is 2, then we have, okay, this is correct. You are going to get 1 plus 1 upon 2 to the power of 99. That's not nice. That's not nice. Oh, come on. Why is this so weird? 1 plus 1 upon 2 to the power of 99. This is surely decreasing, but how? Just how is it decreasing? I don't know. I will do this question the next time. I have to focus on solving this exercise first. So just actually mark this, because this is a very complicated one, which I don't know the answer of. Okay, the next question. Limit x tends to 7 of this thing. So yeah, factorize. So this should be 4 minus x minus x. This should be 7 minus x. Okay, and then here you will have 2 plus the square root of 10. No, 4. Okay, did I do it correctly? Yes, I did. Yeah, this is getting really bad. Okay, where was I? So this is going to be negative 1 upon x plus 7 into 4. So just put 7 into this thing. So this should be negative 1 upon 14 into 4, which is negative 1 upon 56, I think. Next question. N approaches infinity of summation from r equals to 1 to n of r squared upon n. I think we have done this question once. I don't know. So this is just going to be n into n plus 1 into 2n plus 1 upon. Now we have done a similar question, not exactly this. That's going to be like, this is this just cancels, you get this thing. So 1 plus 1 upon n into 2 plus 1 upon n upon 6, and as n approaches infinity, this thing just goes to 0, this thing just goes to 0. So it's just 2 upon 6, which is 1 upon 3. This was easy. Next question. 4 power x minus 9 power x upon x into 4 power x plus 9 power x. Oh, okay. Yeah, and x approaches 0. So 4 plus 9 is 13. That was easy. Right, so just, I think I know. Wait, you have that x over there, but that's not nice. No, that's not nice. So what should we do? Take a derivative? Yeah, that will work. First of all, first thing that I will do is I will just write it as 2 power x minus 3 power x upon x, and then 2 power x plus 3 power x upon 4 power. Okay, what am I doing? Just put x equal to 0, we should get 1. So yeah, whatever. So 4 power x plus 9 plus I don't think this is a nice way of doing it, since as x approaches 0. Okay, fine. So this is the limit as x approaches 0 of this thing. Now this is a finite quantity, so we can just take it out. So that's going to be, I mean, this is going to be 1, right? Yes, this is just limit as x approaches 0 of 2 power x minus 3 power x upon x, and now we can take a derivative. So this is limit x approaches 0, take derivative on top and bottom. So this should be, so 2 power x at 0 is 1, and then you got natural log of 2 minus natural log of 3 upon 1. This was easy, right? So this should just be natural log of 2 upon 3. So log 2 upon 3. Next question. F of x is 2 upon x minus 3. G of x is x minus 3 upon x plus 4. Right. Then limit as x approaches 3 of f of x plus g of x plus h of x. Right. Fine. So f of x plus h of x, f of x plus g of x, that's going to be 2x plus 8 plus x squared minus 6x plus 9 upon x squared plus x minus 12. Right. And then you have to do this thing, minus of 4x minus of 4. No, minus of 2, sorry. So this thing should be, actually just write it as x plus 4 into x minus 3. That's much better. So this is going to be x squared, and this is as x tends to 3. Okay, x squared, and then you got minus 10, no, minus 8x plus, okay, 9 minus 2 is 7, 7 plus 8 is 15. Okay, fine, which is x minus 3 into x minus 5 upon x minus 3 into x plus 4. So this cancels. So now we have to put 3 into that, right? This is just minus 2 upon 7. That should be the answer. Next question. Sine x plus log of 1 minus x upon x squared. Okay, and x approaches 0. This is a weird one. Log of 1 minus x upon x. How can I do this? And you got an extra 1 upon x over there. How will I be able to do that? Right, this is definitely a 0 by 0 situation. So yeah, let's just take a derivative. Maybe we could change this a little. Yeah, because what I am thinking is that maybe we can get something like e over there, because 1 upon x, and yeah. Okay, cool. That's not exactly e, it's okay. Let's just see what happens. Yeah, we will just see. So this is 1 upon x. Okay, sine x upon x plus 1 upon x log to the power of 1 minus x upon x, which is sine x upon x plus log to the power of 1 minus x to the power of 1 upon x, right? And this thing looks somewhat like e, doesn't it? So yeah, we can do it like this maybe. So this is the thing, sine x upon x plus log of 1 minus x minus 1 upon minus x, right? So minus, okay, let's do it like this thing raised to the negative 1 power, isn't it, upon x. Right, and now it looks much more like e, right? This thing raised to that power, this yeah, it looks like e a lot now, right? X tends to 0, so this thing should tend to e, doesn't it, upon x. So this is 1 minus, I don't know, something is off, this should not be that yeah, so it's going to be like 1 minus 1 upon x, okay, upon 0. This is not working. Okay, fine, now what? This is just sine x upon x minus 1 upon x, okay. That's very weird. In that case we will have to use that Taylor series thing, right? I think taking a derivative will be much easier, so we just go with that method. So it's going to be like cosine x plus 1 upon 1 minus x into negative 1, right? So yeah, upon 2x, and now let's try putting x equal to 0 into this thing. So it should be 1 minus 1 upon 0. Yeah, it's still not working, so take another derivative. So it should be 2 negative sine x, okay, fine. And taking another derivative, this should be positive 1 upon 1 minus x squared, yes, and then derivative of the inside, which is once again negative 1, okay. And now try putting x equal to 0 into this thing. Yeah, then it's going to be, this gets cancelled, it's 0, and this is just going to be negative 1 by 2. Yes, that looks correct. So negative 1 by 2 should be the answer. Next question. X approaches infinity of x cubed plus 1 upon x squared plus 1 minus ax plus b equals to 2. Then, wait a second, have I not seen this question once? Okay, I don't know, let's just go and do it. So it's going to be like x cubed plus 1 minus, in fact we can just go for that thing, right? So upon x squared minus 1 minus ax, right? So limit as x tends to infinity of this thing is 2 plus b, limit as x tends to infinity, okay. So this is going to be x cubed plus 1 minus ax cubed minus 1 is plus, so plus, oops, it's positive over there, so it should be minus, in fact. So it's minus ax upon x squared plus 1, x tends to infinity, right? So this should be 1 minus a into x cubed, okay. Minus ax plus 1 upon x squared plus 1, which is limit 1 upon x tends to infinity, okay, 1 upon x tends to 0 of 1 minus a x, okay, that's weird, minus a into 1 upon x plus 1 upon x squared upon 1 plus 1 upon x squared, right? And yeah, so if we want the limit to not be something which is very big like infinity, we would want this thing to be 0, right? So we want 1 minus a to be 0, so a should be 1. So this is like limit as x approaches Okay, so this in that case would just be gone, and what we will get over here is 0. Huh, that's that's weird, very weird, but fine. Okay, let's just go with that. Cool. So this should also be equal to 2 minus b, so that means b should be 2. Fine. A equals to 1, b equals to 2. Next question. Okay. Wow. I hate these questions. X plus 1 to the 10 plus x plus 2 to the 10. Right. And they want us to find what this is going to be. And the good thing is that they only have 100 numbers over there, so maybe it's not like something which is not defined. Yeah, so maybe we can sorry, because they only have 100 numbers, it's not going to be infinity into 0 situation, what I'm talking about. Yeah, so we can just divide by x power 10, right? Yes, so let's do that. This is just going to be 1 plus 1 upon x to the power of 10 dot 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 plus 100 upon x to the power of 10 upon 1. This is not nice. Upon 1 nice. So 1 upon x goes to 0, so this thing is gone, this thing is gone, this thing is gone. So this is just 10 ones, which is 10 upon 1, which is 10. This was easy. Next question. I mean, it was much easier than that n question where you have like, yeah, which I solved, I mean which I didn't solve. Okay, that 1 power and 1 power 99 plus 2 power 99 and so on. That question, that was a horrible one, and I really like that. I want to be able to solve that. Maybe I will. Okay, next question. X e power x minus log 1 plus x upon x squared. Okay, yeah, so it's a 0 by 0 situation, isn't it? So just take a derivative, no problem. Maybe we can divide by that thing. No, really no. So just taking derivative. Is there really no other method? Okay, I mean there should be, right? So 1 plus x squared to the power of 1 by 2. No, there should be some other method other than taking the derivative. I don't know, but for this case, just take the derivative. So it's going to be x e to the x plus e to the x minus 1 upon 1 plus x, right, upon 2x. And now let's try putting x equal to 0 into this thing. Yeah, it's still a 0 by 0 situation, so we'll take another derivative. So that should be, take a derivative, you should get, oh well, this thing is nice. So this can be written as 1 by 2 plus yeah, I think that is correct, plus e to the x minus 1 upon 1 plus x upon 2x. Yeah, that's much better. Nice. Okay, so now we need to figure out what this is going to be. So take another derivative, so this should be like half plus the derivative of this thing, that's going to be e to the power of x minus so it's positive 1 upon 1 plus x squared, right? Yes, that's definitely correct. Okay, and then try putting x equal to 0 into this thing. Yeah, it works. So this is going to be 3 upon 2. Nice. So this is just 3 upon 2. Next question. Right, so once again, inverse functions and stuff. X approaches 0. This is another 0 by 0 situation, isn't it? Think. Can we just break it into two different things and then try to solve it. I think that is going to be a big burden, right? So let's not do that. Let's not do that. But I really want to. Yeah, whatever. Let's just take the derivative. Yes. Always just take the derivative. Fine. So the derivative of sine inverse of x, it's like d theta upon d sine theta, which is 1 upon cosine theta, right? Which is 1 upon square root of 1 minus sine square theta, which is 1 minus x squared. So this is going to be nice. And then derivative of tan inverse of x, that is what's this thing? This should be d theta upon d tan theta, which is 1 upon secant square theta, which is 1 upon 1 plus x squared. Nice. So this is just going to be 1 upon square root of 1 minus x squared minus 1 upon 1 plus x squared upon 3x squared. Okay, and then what? Once again, it's kind of a 0 by 0 situation, isn't it? Take another derivative. Yeah, it's not nice doing this, but we just have to do it, right? So take another derivative. So that is going to be, okay, this is to the power of 1 by 2. So 1 upon 2 1 minus x squared to the power of, hey, wait a second, this is negative 1 by 2, right? So this should be negative 1 upon 2, and this is going to be negative 3 upon 2 and negative 2x. Okay, minus is plus, so plus, then 1 upon 1 plus x squared to the power of 2 times 2x upon 6x, right? So what is this going to be? This cancels, so just get x into 1 minus x squared to the power of 3 by 2 plus 2x upon 1 plus x squared upon 6x. X gets cancelled, and now let's try putting x equal to 0 into this thing. So now it's 1 to the power of 3 by 2 plus 2 upon 2 squared is 4 upon 6, right? So this thing is just 3 by 2 upon 6, which is 1 upon 4, I think. Is this 1 upon 4 or what? Huh? Yeah, well, this should be 1 power 3 by 2. Then you got, and this is not nice, negative 1 upon, why is this happening to me? Oh shit, this should be 1. Yeah, this happens sometimes. So this should be 1 by 2. Fine, so this is 1 by 2, and that's the answer. Next question. Just doing 30 of these questions already make me tired. Okay, x approaches pi by 2 of square root of 1 minus sin x upon, right. I think it's gonna have square root 2 and stuff. Okay, so this is just square root of, actually let's just say that, first of all, let's say that x minus pi upon 2 is theta. This is just square root of 1 minus sine of theta plus pi upon 2, isn't it? Upon 2 into theta, yes, which is square root of, so this thing is 1 minus sine of theta plus pi upon 2. Yeah, that's like cosine theta, isn't it? Yeah, I think that is correct. Yes, that's definitely correct. Upon 2 theta, so this should be square root of 2 sine squared of theta by 2 upon 4 into theta by 2. which is square root of 2 sine of theta by 2 upon theta by 2, and then this is like 4 over there. This thing just goes to 1. So this is square root of 2 upon 4, which is, well, it should be square root of 2 upon 4, right? Or is this something else? Right, so 2 into this is so frustrating. 1 minus cosine of theta, yes. So 2 sine squared of theta by 2, correct. So this is 1 upon 2 square root 2. It's nothing like this, so it does exist. It's not equal to 1 upon square root 2 or negative 1 upon square root 2, is it? I mean, why would it be negative? Oh yeah, I get it now. This actually, yeah, it does not exist. This square root thing, this actually already puts a restriction that this should be in mod. So this is like mod sine theta by 2 upon theta by 2, and this limit actually does not exist because the left hand limit is -1 and the right hand limit is +1. So yeah, it does not exist. So that explains why we didn't get a good answer. Next question. X approaches 0 of 1 minus cosine of 2x into sine of 5x upon x squared sine 3. Now there's no square roots or mod or anything, so I think this is gonna work. Okay, so let's just go with this 2 sine squared of x upon x squared, sine squared upon x squared, so yeah, and sine 5x, which is like, yeah, upon sine 3x. This is like limit as x approaches 0. So this thing should be a limit as x approaches 0 of 2 into 1, because this thing gets to 1, and this is like 5x upon 3x, right, using the small angle approximation. So this cancels, so just get 10 by 3, right? Next question. Okay, x approaches 0 of x cubed upon sine x squared. Wait, is this sine of x squared or, yeah, it's sine of x squared. Huh, funny how that works. So this is just x squared upon sine of x squared times x. So this just goes to 1 and this goes to 0, so it's 0, right? Next question. Wait a second. No, wait. This is, yeah, it's fine. Yeah, totally agree, this is fine. I was thinking that maybe this would not exist, but then it's -0, +0 is the same thing, right? Limit x approaches 0 of sine 3x plus sine x upon x. Yeah, it's gonna be 4. Just use a small angle approximation for this. Next question. Right, so next question is limit x approaches 0 of 1 plus x to the power of 8 minus 1 minus 8x upon x squared. Okay, upon x squared. Yeah, so I think I got it. No, wait. 1 plus x to the power of 8. You know what? Let's actually expand this. 1 plus x to the power of 8. It's like 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, yeah, and then 1, 8, 28, and 56. Oh god, this is really bad. 70, something like that. Anyway, so we only need till this thing. So this thing can be written as 1 plus 8x plus 28 x squared plus 56x cubed plus 70x power 4 and so on. and then minus 1 minus 8x, so this cancels, and this thing upon x squared, so it should be 28 plus 56x plus 70x squared and so on, and then put the limit in this. As x tends to 0, this thing tends to 28. Nice. Next question. Right, sine of integer part of x upon integer part of x. Right, if x is less than 0 and okay, let's go for the LHL. LHL is sine of the integer part of, so it's going to be 0 minus, isn't it? So it's going to be 0 minus upon the integer part of 0 minus, which is sine of negative 1 upon negative 1. Yes, that's how it's gonna be. And it's 0 if it's bigger than or equal to 0, right? So that limit is also 0. So yeah, it does not exist. It just does not exist. Correct. Next question. Right, so even if we go like that, it does not exist. So yeah, I should be doing it. Next question. The value of limit as x to, oh wait, what happened? Okay, next question. Value of limit x tends to 0 of tan 2x minus sine 2x upon x cubed. Oh, take a derivative. Take a derivative. I mean, we could go for Taylor series expansion, but just take a derivative for now. So this should be secant squared 2x and then 2 secant squared 2x minus yeah, sine 2x, so minus 2 cosine of 2x. Yeah, okay. Now it's still not good, so just take it like this. 2 by 3 1 upon cosine squared of 2x minus cosine of 2x upon 3x squared. Oh wait, that 3x squared is not there, so it's just x squared now, which is 2 by 3 1 minus, I think this is gonna work. So cosine cubed of 2x upon x squared, oops, which is 2 by 3 1 minus cosine x into 1 plus cosine x, okay, cosine 2x basically, cosine 2x plus cosine squared of 2x upon x squared. Now just put x tends to 0 into this little part, you get it as 3, right? Yes, so this can cancel with that. Okay, cool. So this is going to be 4 sine squared x upon x squared, right? And this thing just goes to 1, so this is just 4. So 4 should be the value of this limit. Right, positive 4, because if we take x to be 0 minus, we get a positive answer, and if we get if we take it 0 plus, we still get a positive answer, so positive 4. Next question. Ouch, my back hurts. Okay, sine of e to the power of x minus 2 minus 1 upon log of x minus 1, and we have x approaches 2. So this should be a 0 by 0 situation in that case, because yeah, so let's just take a derivative. Should we? Yes, we should take a derivative on top and bottom, right? This is going to be cosine of e to the power of x minus 2 minus 1 times derivative inside, which is e to the power of x minus 2, okay, upon fine, and then let's just put x equal to 2 into this thing. So could there be something more? No, this is it. This is a continuous function, I guess, right? So this should be, I mean, it's at least continuous for the range x bigger than 0. Range, domain, whatever, we don't care about that. Okay, so we have to put x equal to 2 into this thing, right? Put x equal to 2, so just get cosine of, this is 1, so it's cosine of 0, e to the 2 minus 2 is e to the 0, so it's just 1, upon, yeah, fine, just 1. Yeah, next question. Okay, limit x tends to pi by 2, a to the power of cotangent x minus a to the power of cosine x upon cot x minus cos x is. Wow, I'm terrified by this question, really. Yeah, so how can we do this? Think. I think just take a derivative, right? Yeah, just take a derivative. That will solve everything. Correct. So taking a derivative, we get a to the power of. So cotangent x, it goes to 0, doesn't it? So that's why we can just write 1 over there, right? Cotangent x, the derivative of cotangent x is negative cos x squared x, which goes to negative 1 at this point, and then the derivative of cosine x is, oh shit, that's not nice. That is not nice at all, because that's another 0 by 0 situation. So this is worse. This is the worst thing I've ever seen. How am I supposed to solve this? Right, so just taking a derivative won't help. We have to use the Taylor series expansion for this, right? Yeah, just gonna make a bit of Taylor series expansion for this thing. Actually, we should be doing this. A to the power of x is, so put 0 into this thing, you get 1 plus the derivative, which is a power x natural log a, right? So it should be natural log a, yeah, upon 1 factorial, which is 1, plus, so this is upon 2 factorial, which is 2, and the derivative of that, so it should be like natural log a squared, yes, x squared, and so on. So this thing will just be 1 plus natural log a into cotangent x. Okay, actually let's just get that 1 out of this. So natural log a into cotangent x minus cosine x, right? Yeah, plus natural log of a squared times cotangent squared x minus cosine squared x. Okay, plus natural log a cubed, this is upon 2, this is upon 6, into cotangent 3x minus cosine 3x upon. The good thing about these things is that they have a factor cotangent x minus cosine x into this, right, into themselves, and the other factor also approaches 0, so that's nice, which means that upon dividing the top and bottom by this thing, we just get natural log a plus some other stuff which is negligible, right? So that's 0, yeah, because it approaches 0, correct. So this should just be natural log a in that case. Nice. Next question. Oh, I'm not doing this question. I have not done matrices ever, really. I mean, this looks like a determinant, and I have found determinants in physics, so I think it won't be that bad. So we'll just do this. So this is how we find determinants, right? So sine x, cosine x, sine x, x cubed, x squared, x, 2x, 1, 1, right? So this is how we find a determinant. First of all, we take this column. Am I missing something? Right, and then we exclude this thing for finding the thing with sine x. Then we do this. I don't know, I think I forgot how to take the I rarely need it, really. In physics, we rarely ever take the determinant. Yeah. And in maths also generally we don't need it that much, so I have never done that once in my life. So yeah, and I also kind of forgot how to do it. We did learn it in the vectors in physics, not the ones in maths. So yeah, I'm just gonna skip this question. Next question. Next question is f of x equal to cotangent inverse of 3x minus x cubed upon 1 minus 3x squared. Wow, this does not look nice. Yeah. How many questions are left, by the way? Oh, come on, that's not what we want. How many questions are left? A lot, actually. They have to go till 65. Wow. I think I'm gonna stop. Yeah, I'm gonna stop right here, and then I will continue till 65 later. Bye. Have a nice day.